Okay, so today we're tackling something that we see literally every day, but probably don't think much about.
Hmm. Let me guess. Clouds.
Close, but even more fundamental. The color of the sky itself. Why is it blue? Someone sent in this whole video script breaking it down, and honestly, I gotta admit, even I'm kind of stumped. I mean, sunlight looks white to me. So where's all the blue coming from?
Ah, you've hit on a key point right off the bat. Sunlight isn't just white light, it's actually made up of the whole spectrum of colors, just like you see in a rainbow.
Right, right, like all the colors mixed together.
Exactly. We just perceive it as white because all those colors are all jumbled up.
Okay, so I'm remembering back in school using those prisms to split white light. It's kind of like the atmosphere is doing that giant prism trick, right?
You got it. Earth's atmosphere is acting like one massive prism. And here's how it works. When sunlight enters our atmosphere, it collides with tons of tiny air molecules, mostly nitrogen and oxygen.
So it's like the light's bouncing off them.
Yeah, you could say that. And all those collisions cause the light to scatter in all sorts of different directions.
Okay, but how does that turn the whole sky blue?
Well, here's where it gets really interesting. The
Yeah.
thing is, shorter wavelengths of light, like blue and violet, they scatter much more strongly than the longer wavelengths, like red and orange.
Hmm. So the blue's more bouncy.
Exactly. It's bouncing all over the place. And this phenomenon, it's called Rayleigh scattering, named after a physicist, Lord Rayleigh, who figured it all out back in the 1800s.
So it's like a constant blue light party in the atmosphere. That's why we see a blue sky.
You nailed it. That scattered blue light is reaching our eyes from every direction, making the whole sky look blue. Pretty cool, huh?
It is. But okay, new question.
Yeah.
Sunsets. Those vibrant reds and oranges. Isn't that blue light still scattering around then?
Good question. Well, think about where the sun is during a sunset. It's low down on the horizon, right?
Right.
So that means the sunlight has to travel through way more of the atmosphere to get to us, like a much thicker layer.
So even more air molecules to bounce off.
Exactly. And as it's traveling all that extra distance, well, most of the blue and violet light ends up getting scattered away. What's left are those longer wavelengths, the reds and oranges, which haven't been scattered as much. They're the ones that make it to our eyes.
Uh-huh. So the longer the light's journey, the redder the sky gets. Like a filter getting stronger as the sun sets.
Perfect analogy. And this scattering effect, it even explains why the sky seems more intensely blue at higher altitudes, up in the mountains. The air's thinner up there.
Less stuff for the light to bounce off.
Right. Less scattering means more of that blue light reaches us directly.
Now, one thing that kind of blew my mind in this script is that if we were in space, no blue sky, just black. That's wild.
Yeah, it seems counterintuitive, but it all comes down to the fact that space is basically a vacuum. There's just not enough stuff out there, not enough particles for the light to scatter off of, so it just travels in straight lines.
No scattering, no blue sky. Makes sense, I guess. Which explains why all those spacewalk photos have those awesome black backdrops.
Exactly. It's not just an artistic choice. Our atmosphere, it really shapes our whole visual experience.
Speaking of atmospheres, I bet other planets have some pretty crazy sky colors too, right? Since their atmospheres are different.
Oh, absolutely. They all have their own unique compositions, scattering light in all sorts of ways. Makes for some spectacular views.
Like Mars has that famous rusty red sky, right?
You got it. Mars has this thin atmosphere and it's chock full of dust, which scatters red light much more efficiently, giving the whole planet that reddish hue.
And what about Neptune? Always looks crazy blue in pictures.
Neptune gets its deep blue color from, well, it's got a lot of methane gas in its atmosphere.
Methane, huh?
Yeah, methane absorbs red light, but it reflects blue, so Neptune ends up with this intense, almost otherworldly blue.
It's amazing how something as simple as the color of the sky can tell us so much about a planet's atmosphere.
Absolutely. It's a great example of how even the simplest things can have these fascinating scientific explanations.
Before we wrap up, one last thing. Clouds. Made of water, but they're white, not blue. What's up with that?
Sharp observation. It's all about the size.
Mm,
See,
yeah.
the water droplets in clouds, they're much bigger than those air molecules that scatter blue light.
Ah,
And these larger droplets, they scatter pretty much all colors of light equally.
so it's like all the rainbow colors getting mixed back together.
Precisely. And when all those colors combine, we perceive it as white light. That's why clouds usually look white against that blue sky.
So the takeaway here is the color of the sky isn't random. It's a result of this super intricate interplay between light and the atmosphere.
It's a beautiful example of the wonders of nature, really, and the power of science to explain it all.
Makes you want to just go outside and look up at the sky with fresh eyes, doesn't it?
I know I do.
Well, hopefully, this deep dive has given everyone a new appreciation for that blue sky above us. And hey, maybe it'll even inspire you to look up and wonder about the skies on other planets. See you next time.